Good morning, friends. My name is Ashwini Sarvade, and our presentation topic is produce echo in sound using convolution. Now, first, we will see what is echo. An echo is a sound that is repeated because the sound waves are reflected back. Sound wave can bounce off smooth, hard objects in the same way as a rubber ball bounces off the ground. Although the direction of the sound changes, the echo sounds the same as the original sound. Echoes can be heard in small spaces with hard walls, like wells or where there are lots of hard surfaces all around. That is why echoes can be heard in a canyon, cave, or mountain range. But sounds are not always reflected if they meet a soft surface, such as a cushion, they will be absorbed and will not bounce back. Now, what is convolution? Convolution is a mathematical way of combining two signals to form a third signal. That two signal is input signal. In that first is x of n and second is h of n, and third signal is y of n, that is output signal. It is the signal most important technique in digital signal processing using the strategy of the impulse decomposition. Systems are described by a signal called as impulse response. Convolution is important because it relates the three signal: the input signal, the output signal, and the impulse response. Convolution is a formal mathematical operation just as a multiplication, addition, and integration. Addition takes two numbers and produce a third number, while convolution takes two signals and produce a third signal. Convolution is used in the mathematics of many fields such as probability and statistics. In linear system, convolution is used to describe the relationship between three signals in interest: the input signal, the impulse response, and the output signal. Now the overall system is the convolution system. The figure shows the notation when convolution is used with linear system. An input signal x of n enters in a linear system with an impulse response h of n, resulting in an output signal y of n. In equation form, x of n is convolved with the h of n is equal to y of n. In this figure, x of n is enter in a linear system, and the x of n is convolved with the h of n, and we get the y of n is a final output of the convolution. Now, mathematical expression of the convolution. Convolution is a process involving two signals and produce one output. It is mathematically represented as y of n is equal to x of n is convolved with the h of n is equal to summation of k is equal to minus infinity to infinity x of k and h of n minus k, where x of n and h of n are the two signals which are proceed to produce y of n as a result. In above equation, both n and k is a indices. Now, properties of the convolution. The first property of convolution is commutative property. In commutative property, s and h are the two signals. In this property, h is convolved with s is convolved with h in left hand side, and h is convolved with s in right hand side. The both result of that convolution is same. This is a commutative property, and second is a associative property. In associative property, f is convolved with the s convolved with h is equal to f convolved with s with convolved with h. In this property, first s is convolved with h, and that result is convolved with the f in left hand side, and in right hand side, first f is convolved with h, and then that result is convolved with the h. Finally, we get left hand side is equal to right hand side. This is a associative property. In distributive property, h is convolved with the s plus f is equal to h is convolved with s plus H is convolved with F. In left hand side, first S first S and addition with F, and that addition result is convolved with H. And in the right hand side, H is convolved with S and H is convolved with F, and that convolution result is added with the is added is called it's called as a distributive property. Scaling property, A is multiplied with the S into H is equal to AS convolved with H. S is convolved with AH. Fifth one is identity property. H is convolved with del is equal to H. And sixth one is the complex conjugate property. S is convolved with H, and that result conjugate is equal to S conjugate convolved with H conjugate. The result of both is same, is called as complex conjugate property. Now how to solve the convolution? X of n and H of n are the two input signal. The input response is x of n is the input response, and the input response is 1 2 3 1. The zeroth position is 1, and in H of n the sequence is 1 2 1 and -1, and the zeroth position is 2. This convolution is solved by the tabular method, and we get the final convolution x of n convolved with H of n is equal to 1 4 8 8 3 -2 and -1. Now this is a code that we are implemented in MATLAB. First we are give the input from the user x, and the function is audio read audio 1 wave, read the specific voice note, and then subplot that signal, and then plot the x. Plot x means the original voice signal is plotted, then length of the original signal, and s is equal to x and 1. This is a 2D version of the length, and d is equal to 75000. This is a delay of that signal, and the sampling frequency is 44100. This is a sampling frequency, and then delayed length is calculated, and then impulse is given to the signal, the zeros size x and 1, then t10 is equal to 0.6 is the impulse magnitude, and td is equal to 0.6 is the impulse at delay. Then subplot that signal, then plot the impulse response, then convert the time signal and the input signal, then subplot that, and then plot the our output signal, that echo sound signal. This is the overall code of the echo in sound using convolution in MATLAB. This is the output of the code. The first one is a inputs, then time signal is given, and we get the echo signal. This is a y of n is a output signal. We give the response, we give reference from this link, these various links. Now thank you very much.